Today we are going to record another session which is on gamify dApp, that is Tic-Tac-Toe dApp on the aelf blockchain. This dApp is a decentralized gamify application which will allow the users to play the classic Tic-Tac-Toe game on the aelf blockchain. It simply offers interactive interface where two players can compete against each other with game data securely being stored on the blockchain. The purpose of this Tic-Tac-Toe gamified dApp is to demonstrate how traditional game can also work on the blockchain ecosystem and especially on the aelf blockchain, which actually ensures transparency and immutability of the game outcomes and removes the cheating in the game application. In this particular video, we will talk about how to develop this whole dApp on the gamify application, where we will complete this whole tutorial in 4 steps. The first step will cover the setting up of the development environment, where we will set up all the prerequisites. In the next step, we will develop our smart contract for the Tic-Tac-Toe dApp, or you can say Tic-Tac-Toe game. And then in the third step, we will deploy our smart contract on the aelf blockchain. And in the fourth and the final step, we will interact with this dApp smart contract from the front end, where two players will come and provide their inputs. To complete this particular tutorial, you should have basic knowledge of terminal commands. You should have an IDE installed, that is VS Code. If you haven't installed VS Code already on your system, you can click on this link and download for your operating system. You also require .NET 6 SDK to be installed on your system. If you haven't installed, you can click on this link and you can install based on your operating system by downloading the binaries which are required. I'm skipping the step of .NET 6 because I will check whether it is already installed. If it is already installed, then I will skip this step. As I can see, the .NET 6 is already installed on my system, so I will skip this step. In the next step, I will install the aelf contract templates. So I will copy the next command where I will install the aelf contract templates. I will paste this command inside my terminal and it will install the aelf contract templates for me. Aelf contract templates contain some predefined templates which makes the development easier on the aelf blockchain for the smart contracts. In the next step, we will deploy the aelf deploy tool. So aelf deploy tool is required to deploy the smart contracts on the aelf blockchain. When you install the aelf deploy tool, then please remember to export the path which is given at the end of the installation process. I will copy this command and will paste this inside my terminal. If it is saying that it is already installed, then it means it is already installed on my system. There is a note that shows when you use aelf deploy that aelf deploy is not available and there is no such command. You can uninstall and install the aelf deploy tool again. Let's install nodejs in the next step. So I will first check whether I have installed. So I will check the node version. So node is already installed on my system, but I want to use node 20. So I will change the version while using the application. Then in the next step, I will check whether yarn is installed on my system or not. So I will check the yarn version with yarn -v. So yarn is also already installed on my system. If you haven't installed both of these, then you can click on both these links and install based on your operating system and based on the latest binary which is available for your operating system. Then in the next step, we are going to install the aelf command. So aelf command we will install using npm. So we will copy this command and we will paste this command inside the terminal, which will install aelf command for us. It is asking for sudo permission, provide sudo permission, which will ask to enter your password inside the terminal. It will complete the aelf command installation process. Aelf command is a CLI tool which actually helps us interact with the aelf blockchain, which enables the task of creating the wallet and doing the transactions on the aelf blockchain using that wallet. It might require some permissions, so you will have to provide the pseudo privileges for this particular step. This step actually ends the process of setting up the development environment. So once we finish this step, then we will start with the development of our smart contract. As you can see, we have finished the installation. Now we will start with the development of our smart contract. In the next step, we will create a new directory for our Tic-Tac-Toe dApp application. So I will create this directory. So I will first go to aelf tutorials. Then I will create this directory using the mkdir command. So I will copy this command. I will paste this command inside the terminal, which will create a new directory for me inside aelf tutorials folder. You can create your own folder. Then I will change the directory to this particular directory, that is Tic-Tac-Toe dApp. And then I will also create a new aelf template using Tic-Tac-Toe. using this new command, that is .new elf -n tic-tac-toe. So it will simply create the app for us. So once you run this command, you should see the source and test folder. If they are visible when you list all the folders, then it means the last step was successful. So now, as you have created a basic template, now we will add the smart contract code. As we are writing the application for the Tic-Tac-Toe project, so it includes various functionalities like starting the game, then allowing players to make the moves, and then retrieving the game condition like the actual status, the current status as well, and if checking if the game has been initialized or not at a particular time. So now we will have all these functionalities: starting the game, making a move in the ongoing game, then getting the board details, getting the current status of the board, whether a particular player has won or not, and getting the initial status. So we will first change the directory to the source directory. But before that, let's first open our tic-tac-toe game inside VS Code. So we'll go to ELF tutorials, where we have created this tic-tac-toe dApp, and it will open, and then you will see the structure as like this, where there is a source folder and there is a test folder. Now inside source folder, you will see a protobuf folder, and there are 3 other files. One is tic-tac-toe C# file, one is C# project file, and one is the state file. So now we will edit these files to make our smart contract. Then in the first step, we will rename the file hello world contract.proto to tic-tac-toe.proto. That is inside our protobuf contract folder. So proto files actually defines all the functions which are part of a smart contract. So we will copy this name and we will rename the hello world contract.proto to tic-tac-toe.proto file. So we will rename this file. Now we will open this file and we need to change the content of this file. Now the implementation of proto file actually includes the definition of all the functions which are part of the smart contract. So there you can see there are methods like initialize. There is a method called start game, making a move, then getting the board and getting the current status of the game. The proto file also includes the function to get the initial status, and also there are messages or events which we can fetch in between as well without calling the blockchain. So its events are emitted when there is a certain action taken in a particular function. So there are 3 messages defined. One is move input, one is board input, one is board, and the next is the game status. So what we will do is we will copy this proto file and we will select all the content inside the proto file, that was the hello world contract. As we have renamed that file, now we will paste the new content here and we will save the file. This proto file defines all our RPC methods and also the messages of the smart contract. Now we need to define the state. In the next step, we will define the state. But before that, as RPC methods are the functions written in the smart contracts, which actually allows the external users to interact with the smart contract. And the messages actually represent the structured data which is exchanged between the contract and any external system, which can be a dApp or which can be through command line as well. So in the next step, we will define the contract state for tic-tac-toe. So as we have seen another file, that is tic-tac-toe state.cs inside the source folder in our project. So we'll see that there are certain states defined. One is the board state, one is the current player state, one is the game status, one is the winner, and whether the smart contract has been initialized or not, and who is the owner of the smart contract. So these are some states which we have defined for our tic-tac-toe smart contract. So we'll copy this file and we will go inside source folder where we have a state file, and we will select the whole content and we will paste the new content which we just copied, which defines all the states of the tic-tac-toe game. Now, in the next step, we will write the logic of our tic-tac-toe smart contract. Before writing the logic, let me explain the significance of the state file. Actually holds the variables that stores the contract data, which makes sure that this data is saved and accessible whenever the contract needs it. So now, as we have already defined the state file, now we will move to the implementation of tic-tac-toe smart contract. So now there is a file called tic-tac-toe.cs, that is a C# file which include the logic of the tic-tac-toe smart contract. So now here we can see there is a smart contract written where there is an initialize function, where if this function is called from outside, it means it will initialize the smart contract. So to interact with the smart contract on ELF blockchain, we first need to initialize the smart contract. Then there are other functions like start game, which will help to start the game. And then there is a next function that is make move, which will help players to make the move inside the game. Then in the next step, it also checks certain conditions like getting the existing board array, then checking if there is a winner already, and if the board is also full. Board might also be full without anyone winning the game as well. So in the next step, there is a function called get board game, which actually gets the board status. And then there is next function that is the get game status, which actually tells what is the current status of the game, whether a particular player have won or whether the board is full or not at a certain time. Then there is a function to get the initial status of the board, the function to reset the board to initial state, and some private functions to reset the board. Private functions can be called inside the smart contract only. Then there is a get board array function. These are some helper functions which actually helps the other functions to get the board array and save the board at a particular time, and also check the winner if somebody has already won the game and if the board has been full at a certain time. Now, these are all the functions which are defined inside this smart contract. So we will copy this and we will paste this inside our smart contract file. We will copy the implementation of Tic-Tac-Toe smart contract and we will go inside tic-tac-toe.cs file inside our source folder. We will select the existing content and then we will paste the new content, that is the new implementation of the Tic-Tac-Toe smart contract, and we will save the file. Now we have done the implementation of our Tic-Tac-Toe smart contract. So this finishes our second step, that is the development of the smart contract. But before moving to the deployment, let's build our smart contract first. So we will build this smart contract which we just deployed. So we'll copy the next command, but make sure you run this command .NET build inside source folder. So first we need to change the directory. So I will open the terminal. Inside terminal, I will first go to the source directory. Then I will check the node version here. Node version should be latest, that is node version 20. I will use NVM to use the 20 version. You can also use NVM to change the node version. And now I will do the .NET build. It will build our smart contract code. So it means it will create the binaries, and the output of this particular step is to create the bin folder inside the source folder. And there is a .dll.past file which is created, which will be used later, and it is the outcome of the build step. So this file is used when we deploy the smart contract. It means that we have completed the step of building the smart contract successfully here if we have created the .dll.past file for the smart contract which we just developed. This completes our second step of the development of the smart contract. And then now we'll have to move to our next step, that is deploying the smart contract on the ELF blockchain. To deploy the smart contract on the ELF blockchain, we first need to create a wallet. To interact with the smart contract or to deploy the smart contract, we need a wallet which helps us do the transactions or interact with the ELF blockchain, or with any blockchain we require a wallet. Now let's create that wallet inside our terminal. So let's copy the next command, that is elf command create. Elf command we have installed in our first step. So it will create our wallet. So now let's first create the wallet. It will output 4 information, that is private key, public key, mnemonic and address. Mnemonic is a other form of the private key or a simpler form of the private key. Similarly, address is also a derived form of the public key. So now we will save this information in a file. We will provide the password to the file, and we will confirm our password to save this information inside the file, because this is a sensitive information of the account which we just created in the wallet, or you can say is the wallet which we just created. Now, in the next step, as we have saved the file, if you choose N, then you might not to set the environment variables in the next step, but it is always advisable that you encrypt this information in a file with a password. Now we will export some environment variables which will be used later on to get the tokens through faucet and to deploy the smart contract as well. Our next step is to export the first environment variable, that is export wallet password. My wallet password is the password of the file which I just set. I will set, and my password was Mohit at 123. I will set the password first. In the next step, I will set export the another environment variable, that is the wallet address. Now, wallet address is the address which we got in the step of the elf command create, and this address is our wallet address. We will copy this address and we will paste it here, and then we will set the another environment variable, that is wallet address. Now we will get some tokens through faucet. We will call the faucet command. This particular faucet will give us some tokens to deploy the smart contract. Here we require which wallet to transfer these particular tokens. We require this wallet address. Now let's copy this command and then paste this command inside our terminal to get some tokens, elf tokens, to deploy the smart contract inside our wallet, which we created using elf command create. It will get us some tokens. Now we can verify this whether we got the token successfully or not by calling the get balance command. So if success is true, it means the faucet command ran successfully, but we will still verify using the get balance command. Now the next command will again call the multi-token contract, which is a elf multi-token contract, which manages all the tokens on elf blockchain, and it provides the wallet address and the wallet password for which we are checking the balance, and it calls the testnet node where the testnet is running for elf blockchain, and it calls the function get balance. So now we will enter this command to check our balance. It will ask us for which token we want to check the balance. So we want to check the balance of elf tokens, that the symbol for that token is ELF. The owner is the address. Here is the owner address. So we'll copy this and we will paste it here. And then once we enter, we will see some balance inside. If we see some balance which is greater than 0, it means that the faucet worked successfully. Extra 8 zeros are for the ELP tokens, which is up to 8 decimal places. It means we got 100 ELP tokens to deploy our smart contract and interact with smart contract function on the ELP blockchain. Now we will deploy this Tic-Tac-Toe smart contract. But before deploying, we have built our smart contract which generated the .dll.tpast file. So now we will copy the contract path and we will export it inside our terminal. Using this command, you can directly export the contract path. So we will run this command inside a terminal, which will set the path to this file, that is tic-tac-toe.dll.past, which will be used inside the deployment step. Now let's copy the next command, which is elf deploy command. Now let's copy this command to deploy our smart contract. So we will copy this command. So what this command does is it uses the elf deploy tool and it provides the wallet address and wallet password to do the deployment, from which it will use the elf tokens to deploy. Then it will use the contract path where our build file for the tic-tac-toe game is present, and then it will call the testnet node to deploy. So we will copy this, then we'll go inside our terminal and we will paste this, which will deploy the command. If you get this particular thing, that command not found elf deploy, so what you can do is you can uninstall the elf deploy tool and then you can install again, where you might have to export the path. So you can copy this path and then you can paste it here. Once you do that, if you run the elf deploy command again, it will start deploying the smart contract. So the deployment process actually includes taking the smart contract code from, like you can say, from this ecosystem, from the terminal to the elf blockchain. So it means the code, the logic which we wrote for tic-tac-toe game, it is actually now going to a particular storage on the elf blockchain, which will actually help us in future to interact with all the functions which we just wrote inside the logic of this smart contract to interact from the outside. What deployment actually does is takes the code to the blockchain and then allows the users to interact with the logic of that smart contract after the deployment. Also, once the deployment happens complete successfully, then what it does is it actually provides you an address. So that is the identity of that storage where this code is getting stored on the ELF blockchain. So ELF blockchain will provide you an address, that is the contract address, which we will use to interact with the functions of the particular smart contract which we just wrote. So it is similar to an ID of the smart contract. As we can see, the deployment process completed successfully and it is showing that the contract has been deployed. So here you will see an address. This address is the smart contract address which we got from the aelf blockchain where the smart contract has been deployed. So we will use this address while interacting with the smart contract. Now let's move to the next step where we will export the contract address. So now as we will use this contract address somewhere, we need to export this environment variable so that we can use it later on. So we'll export the contract address inside the terminal. This marks the completion of our third step. So now we have successfully deployed our Tic-Tac-Toe dApp smart contract on the aelf testnet. And now we will interact with this deployed smart contract using our dApp. So now for that, we need to first get the front end sample. So we have created some samples to start the front end application and then there write the logic of the functions to interact with the smart contract code. So now first we will clone this repo, which will help us to interact. So I will go inside aelf tutorials, clone this repo, and then it is saying that aelf samples already exist. So I will maybe go inside that and then I will pull the new changes. Now we will open the aelf samples. So we will open this and we can see there is a sample for the tic-tac-toe game. Now there you will see two folders. One is for the smart contract that is provided for the ease so that you can check the smart contract code if you have made any mistake while developing and deploying the smart contract. And second is for the dApp. So there we have written the template code for the dApp of the tic-tac-toe game. Now we will first change the directory. So we will go to dApp folder first. So now as we are only in writing the front end code right now, so we will change to that folder. So first we will go to our tic-tac-toe game. Then inside that there is a dApp folder and we will change the directory to that folder. Now we will see that the structure of the code is like this. If you will open that, the structure you will see is like this inside. This is the structure of our dApp. Now, in the next step, we will install the packages and libraries required. There is a package.json file where there are certain dependencies defined for this tic-tac-toe game. We will first install them using the npm install command. You can use sudo if there are any packages which requires the right permission to add a folder in your operating system. So you might use sudo. So it will install all the required dependencies which are inside package.json file and it will help us run the application by installing all the dependencies. But before running the application, let's first write the logic of interacting with this smart contract using the front end. So in the aelf blockchain, to interact with the smart contract code, we need to install the PortKey wallet. So this is the PortKey wallet. You can check on the Chrome extension. So you can search PortKey extension. And then here, if you haven't installed PortKey wallet, so you will get an option to add to Chrome. So it is recommended that you run the dApp inside Chrome application for better behavior. So you can install it as I have already installed. So I will log into my PortKey wallet. So now I have logged into my PortKey wallet. I will check whether the dependencies have been installed or not. So it is still installing. So now what we will do is we will configure this wallet. So now as dApp is a separate application, so we need to interact with the smart contract code with a separate application, but there should be a way to interact with that. So now we will use the PortKey wallet to do that. So first we will check whether inside where our application is running in the browser, whether a provider is present or if it is present, then we will connect to that provider and provider will be our PortKey wallet. For that, we will go to the step A inside our use smart contract.ts file inside the source hooks and use smart contract.source and hooks folder. So then we will write the code to fetch the provider and then we will also fetch our smart contract as well. But to fetch the smart contract, we need something and that is our smart contract address. So we will provide our smart contract address here and then it will simply fetch the smart contract code from the blockchain on inside the front end application, and we will instantiate that to interact with the functions. So now let's copy this code and let's check whether the installation process was complete or not. It is completed. So now let's go to source. Then inside hooks, there is a use smart contract.ts file, and there is a step A. So there is an incomplete function written. So you can just paste the function which will fetch the provider and then will fetch the smart contract. So before completing or saving this function, let's first get the address of the smart contract. So now let me just get the address of the smart contract. So here we will get the address. So this is the address which I will copy and paste inside my code. So this will help us fetch the smart contract code inside this front end application. Now we will move to our next step, that is to initialize and fetch the smart contract. So now we have fetched the smart contract, but we need to now initialize it to interact with the smart contract functions. So what we'll do, we'll go to the step B and we will implement this use effect hook. So here you will see an incomplete implementation of use effect hook. We'll just simply select this one and we will paste our code here. So our use effect hook is complete. Paste that. Now it will return a smart contract. We will save that. As we have implemented the fetch contract function inside that, so it means we have initialized our smart contract and step B is complete for us. Now we'll save this file and now we will move to our next step. So this hook actually initializes and fetches the smart contract when a particular provider changes. So for example, if you log out or let's say if you uninstall or something like that, so it fetches the latest state. Now, in the next step, we will connect the wallet. So now we have fetched this provider inside our browser, inside our application, right? So now we need to connect to this. So it means we need to make a connection between our application, that is our dApp, and between the wallet. So now we'll go to another file that is inside source component layer and header folder. And there we will write the code to connect our PortKey wallet. So here we will first connect, then we will fetch the accounts inside the wallet, and then we will set the wallet address to show on application screen, which you will see when we will run the application. So let's copy this file inside source components layout header folder. So let's go inside source component layout and then header folder. There is an index file and there is a step C where we need to write the implementation of the connect function that will connect the application with the PortKey wallet and will fetch the addresses of all the accounts, and it will show the account address as well, and it will also show a notification that the wallet is successfully connected once the successful connection is done. Now in the next step, we will check the contract initialization, whether the contract has been initialized or not. So now, as this is a check, or you can say before calling the function, we need to check whether the smart contract has been initialized or not, right? We wrote an initialize function in the smart contract, which needs to be initialized before interacting with other functions of the smart contract. So we will first write that information, whether it is initialized. So we will copy this and we'll go to step 1 inside source pages home, and there is a index file. So inside source pages and there is a home folder, and then we need to search for step 1 in the index file that actually checks whether the contract has been initialized. So here there is an incomplete implementation of that function. We will complete the implementation and we will check what is the initial status of this smart contract. Now in the next step, if the smart contract is not initialized yet, then we will initialize the smart contract. So we will write the initialize contract function. It will simply call the initialize function inside the smart contract, and it checks by calling the get initial status inside the smart contract which we have written. Now we will copy this code which will initialize the smart contract and then will tell us whether the smart contract has been initialized by a toast, and then simply calls the smart contract method which is initialize and then update us whether it is successfully initialized or not. So now let's copy this and we need to now go to step 2 inside the same file. So there is a step 2 to initialize the smart contract. So we'll select the incomplete function and we will complete the implementation. Please avoid duplication of the code. Now in the next step, we need to fetch the game status. Now as we have initialize the smart contract. It means now we can check the game status. Let's say if the smart contract is initialized, we can check the game status in between. There is a logic written in the get game status function. In the step 3, in the same file, we will write the implementation where from the smart contract, we will call the function that is game status. That is a callable function to fetch the data from the blockchain, and then we write the logic to console the information and to show the notification and to handle the errors. So we'll copy this and then we will paste this code inside our step 3, that is to fetch the game status. There is a incomplete implementation, so we need to complete that implementation and we will save this information. Now in the next step, we will fetch the get board data. So now board can be in any state at a particular point. So we need to get the latest board data. So again, we'll call the get board function inside the smart contract, and then we'll get us the result and we will show the results on our front end, and then it will handle the notifications and errors accordingly. So we will call this function, we will copy this code and we'll go to step 4 and we will complete the incomplete function which is already written, and we will save this information and then we will again go back to the step 5. Now we have configured the provider, that is our PortKey provider. Then we check the provider is like connected or not, or you can say we connect with the provider with the application, and then later on we initialize. First we check whether there is an initialization, then we initialize the contract, and then later on we actually fetch the game status. Now we will start the game. So now we will write the start game function. So we will copy this file. Start game also calls the smart contract function, where it calls the start game function, and then it gets us these things using get latest board, whether this function is started and which player's turn is this, and then it will show the notification whether it has been started or not. So we'll copy this code, we will go to step 5 where we will change the incomplete implementation to complete implementation of this code, or you can say the start game function. Then once the game has started, now players will make the move. Now we will write the implementation of making the move. So there are two players. So X and Y we are considering as two players. Then first will X will make the move, then Y will make the move. So we will write the implementation and we will record these move inside our blockchain, and we will call the make move function inside our smart contract for that. So we'll copy the code and then we will go to step 6 where we will make the move, or you can say players will make the move using this logic. We will save the file. Then in the next step, will have to run the application. So now as we have completed the implementation of configuring the provider and then connecting with the provider, then like fetching the account from the PortKey wallet after the connection, and then checking the contract initialization, and then we initialize the smart contract, then we fetch the board data game status, and then we start the game, and then players makes the move, and based on those moves we announce the result as well. So now let's run the application. So we'll copy this command and then we'll go inside our terminal and we will paste this command and we'll run our application. So this will run our application. So it might show e-access permission denied error. So to avoid this, you can provide sudo. So it might create some folders for you, some artifacts. So you can give sudo permission. So now it will run the application. So now let's see how the application is running. So we will run this application, and here we can see the application is running and it is connecting with my wallet. So as the wallet is already open, so it is already connected. If I click on this, it will show that it is successfully connected. If I log out from wallet, it might ask me to connect again. So you will get a connect wallet button. So now I have the start the game functionality there. So I might start the game. So now it is initializing the smart contract. So I will sign this. So as I said, we first need to initialize the contract before interacting with the game. So now I need to sign again to start the game. So I need to sign a blockchain transaction. So these pop-ups, two pop-ups actually are interacting with the blockchain as blockchain smart contract. So now it is showing which player turns is there. So active is X. So now I can make a move for the X. So now I will have to record this step, right? So now I will sign this again, and this information will then be recorded on the blockchain. When this particular step is completed, then it will fetch where player X actually made the turn. Now player Y, it will show as 0. Let's say for example, player Y starts, let's say here player A starts. So now here I will again sign the transaction on the behalf of player Y. Now it will sign this transaction and will populate the value for player Y. Now it is the turn of player X again. So we will make another moves. We will again sign the transactions till the game either draws or one of the player wins. So now I will make the move on the behalf of the player 0. Now I will just sign again this transaction. Then I will provide the next step for the player X. And if I press here and sign the transaction, it means the player X will win this game, and it will show the completion of the game as well once this steps concludes. So now I will get the game status, and here it will say the player X is a winner, and it is congratulating the winner, the notification. And you can also play the game again by starting the game again here. So now we have completed the functionality of running the application inside our browser. So where we did all our steps. So now, as we have successfully ran, if you face any issues, you can go through these steps, how to install the PortKey wallet, how to select the network, how to connect to the wallet, how to get the tokens from the faucet. All these steps you can follow, and then how to play the game, start the game. All these steps you can follow here. And once you reach the winning position, then it means you have successfully concluded the Tic-Tac-Toe dApp application. This particular application actually is aligned towards gamify theme of our aelf blockchain. So here we have successfully completed a game application, which is a standard Tic-Tac-Toe game, which allows to store the game data on the blockchain and verifies the information, and it avoids the cheating on the game infra. Stay tuned, keep learning with us. So this is the another segment where we are talking about games. We will come up with more such tutorials, and keep learning on aelf blockchain. You have gone through these 4 steps, and you can enhance the game logic, you can improve the security, you can check out our cross chain capabilities as well, and you can expand this particular game according to use case. This was all about this particular tutorial. Thank you so much for tuning in again, and keep learning on aelf blockchain and keep deploying new applications on aelf blockchain. Thank you.